Hello. Great. Okay, I think we have almost everybody. Anyone who doesn't know me, I'm Owen Bailey, one of the organizers. Sean is not here tonight. He usually does all the emceeing and introductions things, so forgive me. For anybody who doesn't know, we record all the sessions. We kind of consider them pretty open, and they all end up on YouTube eventually. I think we're pretty up to date at the moment. Gene is here. He usually puts them all up for us. So if you don't like it, don't look at the cameras or leave. So the agenda for the evening, we've got, or no, we've had a change of order, that's right. So Simon is going to kick us off with his final year project. It's visualizing historical data, how he built it, how he got there, all the tech stuff. And we've got Marco Forte talking about Arduino development, if I'm right there. Marco is starting his leaving cert next week, so good luck with that. And then we have Mark Dennehan, who is finished up final year in DIT, talking about his Security Shepherd tool, which covers the top 10 security risks for OWASP. Got all that correct. We've got a couple of announcements, some of which are already out on the mailing list, but I'll cover all that again at the end. And then we usually go around for a quick drink in the schoolhouse pub, or sometimes several drinks. So I'm going to pass it over. You're ready, Simon?
Yep. Thanks, Owen. All right. Hi everyone, I'm Simon Maishman. I'm just finished 4th year in Trinity, Computer Engineering, and this is the final year product that I did. It's visualizing historical data. This is a database of the statute staples, which covers the 15th and 16th century. It's important because it covers the 1641 Irish Rebellion, the Catholic Rebellion, and we have some very smart people, historians in Trinity, who know all about this, but don't unfortunately know about how to access MySQL and get the data out of there. So the aim of this project is to close the technical gap between accessing the data from databases and being able to analyze it and create graphs and do whatever you want, mine the data in order to have some use and to access this pretty cool tool, pretty cool resource we have. So this is what I'm going to be talking about, a demonstration of the final year product, briefly touch on the architecture, how I built it, and then go through a couple of problems that I had, and then any questions. So this is my research question. Fairly waffly, you know, the main point of this is it's a web-based interface for non-technical domain users. So these are the historians who are writing theses on this kind of area, and they need to be able to access this data and draw conclusions from that, and so they need to be able to support non-technical users and visual querying and explanation. So one of the key features of this project is that it's user-centric, very user-centric. So we were talking to the users very frequently along the design cycle. So it wasn't a traditional final year product. So you didn't have a big design phase and then one long implementation phase. It was about 8 short iterations of design and implementation, talking to the users, discarding some stuff, improving other stuff, and then working on bringing more of that stuff and moving on to more features. So now I'm just going to flip over to my demonstration and actually work through the actual tool that we have at the end of the year. Okay, here we have, this is the tool, this is the screen that you see when you load it up, and we'll start with the first set. You can see we have 3 general areas. We have the graph, we have the control box, and then we have the ticker tape, and we'll talk about the ticker tape later. So you can see that we're querying at the moment. We're querying date is on the x-axis. We're querying both the British and the Dublin records. Debtors, we're querying the amount. We've got a bar graph, and the amount we're querying is from 0 to 100 punts, or whatever the currency was back then. So the key thing we're looking at is we want to be able to extract the data. We want to mine down to the raw data from the database. So if we click on one of these, we get all the data in our own database. So you can see here we've got 6 transactions, and the details of all 6 are out here. We've got the names, we've got their occupations, and you can see that it's all below 100 punts. And then we can get that in a different tab. We can get the graph in a different tab. This is very key because for historical users, this is something I would never have guessed myself, but they need to be able to source every single graph to a unique URL. There's no point being able to say, I followed these certain steps to get this graph in their thesis. You'll be able to say, this is the URL, this is exactly where you get this data. I can back up my findings and my searches right to this single point. This was a key feature that we had. And we can also save the data to a CSV if anyone wants to use it in Excel. It's German CSV separated by semicolons. So there we go, it's downloaded there. Right, now we move on to the dates. We have 3 different date enterings. We've got a very specific one, so if I want to move into the September of 1604, and we'll go on the 8th, and we can change it. And you can see the graph has changed. Then we have these nice sliders. This means that we can get more or less years, so this is quite helpful for our users. They want to be able to mine from wide to specific. So for example, if we move this right to the end, we can get a general trend of what's going on. So you can see in the 1941 area, very few financial transactions in that area because of the rebellion and the civil unrest that was happening then. Then we just got standard more and less years. Then we've got our input settings. So we've got the standard ones, which is the type of graph we want. So we've got line graph, we've got scatter graphs. We've got we're querying the debtors or the creditors or both. So we can add them or take them away. And we've also got the specific queries that we have, and these are in 2 parts. So we've got the general query, which is the amount, the occupation, or the location. And then we have the specific ones on the further down. I'll actually move this. And so you can either see, you can go 0 to 100, 100 to 200, 200 to 300, and then we get excess graphs in, so you can get a lot more data, and you can get as much data on the graph as you want. And as you can see, these are all very easy to use tools. These are button input. So all our historians who would be, wouldn't know SQL, wouldn't know any of that, wouldn't know scripting languages or visualizations, they can all, use this tool in a meaningful manner and get some results out of it. So when we move down, we have a total button as well. This is quite a powerful tool. So, for example, if you wanted to see the general amounts from 1,000 to 3,000, or for gentry, trade, and merchants, you've got the total there. That's the total that's been selected, not the overall total. If you wanted the overall total, you just select everything and then grab the total. So that was one of the things that the lads in the user group were very keen on. And another thing that they were incredibly keen on was ticker taping. This means that, as you've seen, I've been fiddling around lots of different graphs. They've all propagated down here. So if I was doing some research and I thought, these are all great, except this graph shows me nothing. I don't need this graph. I can print everything else off and show my findings and my research, but this is messing up my results. You can delete this, and then you can just print them all off and use these in your records and in your theses or any other research you're doing. And you can always start again as well. Okay, so that's a general overview of the project, and we'll go back to the demonstration and some more in-depth architecture. Okay, this is my architecture model. This is very simple, standard web-based architecture. So we have, you just saw there the application layer, bit of HTML, JavaScript, jQuery, client-side functionality. The aim was, it's very important for our users to have a rich internet application, as in no refreshes. They wanted to be able to keep all, as you see on the ticker tape, all of their previous graphs, all their findings. They want to be able to see a waypoint of how they got to their data. So it's very important that we didn't have refreshing, so there's lots of client-side coding. Then we have our graphing layer. This is where the graphs have come from. The graphs are the images that you saw were embedded images. They come from a different layer. This is a web service. This is a REST web service. So you just change the state. You can actually, for debugging or customizing, you just change the URL, and the state of the image changes, and the graph will change in turn. And we also have the data layer, which mines the database, the primary source. This is also, it was meant to be Perl, but it's a PHP. It's a very simple XML based web service. So if you make a query, the application layer, the buttons you press, that changes the request that's made to the graphing layer, which also propagates these values onto the data layer. The data layer customizes its search, customizes its SQL query to the database, which then returns the data. Database layer formats that into an XML format, which the graphing layer can use. Graphing layer mines that data and then produces a graph that will show the user what we want to see. I've just got a quick demonstration of all that working. So here you go. You can see this is a graph. It's got two different entries, 0 to 100 and 0 to 200 over the 1600s to 1609. And if we go to the data layer, here we have 10 entries, the first 10 entries, then we have the second 10 entries, the two labels, and the years. And this is the data. This is actually the pure data. This is my database. And the way it's searched is, if you want creditors, you just search the creditors table. If you want debtors as well, you search the creditors and the debtors and the relationship between the two. And then the actual details are all picked up from all three. So we can actually change our REST-based query here. So if I add an extra table here, so I can go for 4. There you go, there's another line. And if I can do the same thing on my data layer here, and you see we get another layer here. So these are how these are all connected. Right. And now we're going to talk about some of the problems that I had when I was making this. As I said, I'm going to talk about the general problem areas and then go to some specific examples, get a bit technical, depends how time goes. So we have, as I said earlier, this isn't a traditional final year project. Traditional final year project, you'd have very basic requirements, how you deal with those requirements, and then you move on. You have a 2-month, 3-month development phase, and then you get something at the end and you write it up. Now we had about 6 or 8 very short development cycles. This means we had a rapid prototype. So all of the functionality was prototyped quickly, shown to the users. We like that, we don't like that, change that. Went back, changed it all, made it solid, made it actual function that you can depend upon, and discard other stuff. So this means that you quite time pressurized. So you're looking for a quick solution to show the users, rather than a solid, stable solution that would be able to be built on. Because I wasn't sure that it was worth putting the time in, something that was going to be discarded at the next meeting, or it would be changed, or I wouldn't get it finished at the time. We've got to be able to show them actual a final use, so a usable solution at that time. So 3 areas that it was especially noticeable was the feature selection, which was the checkboxes as you saw there, ticker taping, which is actually a complete pain, and the skipping the data layer. So for the first 3 meetings, my visualization layer and my data layer were actually the same. It was mining the database right from there. Okay, so we had titles. As you could see, all the ones in the title were actually called new. I had implementation to change the titles, add different specific names for each X and Y axis. These weren't needed. The users didn't really want them, and it wasn't worth the time, so these were taken off. And we had many graph types, lots of graph types from the different graphing utilities. Ended up only wanting the 3 different graph types. So these were quite a bit of work was put into these guys, and then they were just discarded. So they were, it's just how it goes, but that's one of the problems that we had. It would have been easier to get everything to go work on, as you know from any development project. It'd be great to know what you want at the end right at the start. Okay, and this is a bit of an example of a story. As I said there, we got the English libraries and the Dublin libraries. So there's the Statue of Staples. This is taken from, literally transcribed by someone in 1997 from the original paper records onto a digital form into a database. So we've got them from the English records from London and from the Dublin records, and they weren't. I'd completely ignored them until my final user tests, And I was going away testing loads of people, and literally the last user I went up to had all my my sus forms, my feedback forms, my little tasks for them to use, and then give me feedback. And gave it to her, and literally the second thing she said was, "Oh, this is great. So how do I choose which library?" Silence. I was libraries. There's no libraries column. What libraries? Oh yeah. You got the English libraries and the Irish libraries. There's a code there. Did no one tell you? And I was like, I do engineering. I don't know history. And then so it was. This was like a very key feature that we just missed, and we had to go back and create an entirely new query right at the end. So that's, I'm not the expert on this. We have domain-specific experts, and so this is user-centric. So we had to. This is kind of changing targets, I suppose you'd say, right at the end. So that was one of the problems. And then we had the ticker taping the graphs, and this was the most frustrating technical challenge. I wasn't particularly familiar with the DOM or the HTML before this project. So what I really wanted to do was use a linked list, and you can't do linked lists in HTML very well. So it's quite frustrating. The key is you've got to have a header, a parent, and then you've got to be able to add stuff in, but they've got to be pointing to the next one, and you've got to be able to delete a number of entries or specific entry and still have a link to the next one, and to be able to propagate the last a new graph right to the end. So I ended up actually having a jQuery function that wrote the pure HTML to the browser instead of div object or something like that. And this was one of the frustrating areas of development. Year highlighting as well. As you can see, you can mine each of the years, and at the moment the year highlighting is just a little it's the date right in the corner there, not particularly easy to see. The aim originally was to have two different coloured backgrounds and then merge them, and that would highlight each wherever the mouse was hovering. This was quite challenging, just to have the two graphs in storage at the same time and then cut a tiny bit out and hover it over. So this wasn't actually implemented. This is something I hope to do in the future. So this is the overview of the main problems. The user-centric design was design and implementation. So we'd have changes at each meeting. Rapid prototyping led to some problems getting things working, and you'd do a quick fix before you got any stable solution. So you'd end up having to redo stuff. So a couple of changing requirements. The ticker taping was technical. The Perl SOAP web server ended up taking far too long. It would cause propagation delays, and it bugged quite well. It behaved quite well, but it was just the edge cases. And for example, as you saw there's a line graph, and if you only have one query on a line graph, you can't have one point line graph. 1 point on a bar graph is fine, 1 point on a scatter graph is fine, and 1 point on a line graph, complete errors. So that was edge cases had to be looked at, and just in the end, if there's a single query for a line graph, you just add in a second query, so there's a line horizontally going across, and then you've got stress tests to just as much queries as you can and see how it copes with that, and it coped pretty well. So that's me done. If there's any questions. Yeah.
So I just wonder, what was the motivation to do such a cool stuff? Yeah, I mean, because if that's the case, you could use the comfort of the server side, right? Instead using the
Yeah. Oh, yeah. I think I know. What you mean is the question is, why did I have jQuery and JavaScript and server-side scripting if you have to have a unique URL for each?
So you could use the server side.
Yeah. Well, actually, the server side, all the graphical layer and the data layer are all server side. All that calculations are done server side. The presentation is all client side. So the URL of the presentation layer, what I showed you earlier, that never changes. But the graphical layer and the data layer, that changes. That's, I think, PHP on the graphical layer using a graphing library, and so that they do change. They're all server side. but it's just a tiny. It's the image, the source of the image in the presentation layer. That's what changes. So. Yeah, well, I was my hands were slightly tied as far as the visualization layer. I was using a specific graphing library, so that was a PHP like JP graph. So that needed server-side scripting. So it was a REST. It turned out to be a web service that just takes in this URL with all these values in it and returns an image with a specific image with a specific graph. And then the reason that we had the database was hit. Yeah. Well, the motivation for the different layers as well was it's a upgrade and changeable. So you can rip out the data layer, rip out the database, put in a new database of say the 1916 rebellion, and then you can keep the presentation layer and you can keep the visualization layer, so it's independent from each other. And then and the server-side scripting was done because of the libraries that we used and because it can be plugged in. So yeah. Sorry. Any other questions? Well, it's a year-long thing. We didn't have all the bugs figured out and exactly what we wanted to do till about, I don't know, was it September, October, December time? Yeah, around then. So it was working from then till we finished in March, start of March. Started writing the thesis there. We weren't set times. It was just like whenever everyone's free. So each cycle would be about 2 weeks, and I'd have meetings with my supervisor between them times. But that was the official ones when you'd go into a meeting room, and we put it up on the projector and say to Mark, what do you like? Is this good? Is this bad? It would be about 2 weeks. Oh, sorry, Mark was one of our expert users. He was a historian. I had a couple of issues with the data. The database was prepared in 1997 by a history PhD student, and it was you're knocking around the SCSS department on a CD. It was it's something that it's a resource everyone knew was a great resource, but because it was a access database at that point, then the history students they all learn history and how to write a thesis. They don't learn SQL, so they didn't actually have any knowledge to access it. So it was one of those projects I think that was in everyone's mind for a while, and then we came and did it this year. So it was I didn't actually get to meet the person who did who put the data there, but it was great. Some of the problems were as far as getting names. There weren't any specific concrete names at that time. Everyone would spell it slightly differently on each piece of paper. And there was lots of, because it's a primary resource it's copied from. As you saw, I think probably when I mined the data, there's quite a few gaps. So narrowing stuff down was a bit tricky. But the data was quite well behaved generally. I didn't have to I didn't touch it at all because I thought it was more powerful to be mining pretty much a primary resource rather than cleaning the data or doing any manipulation. The pros we'd get wouldn't outweigh the cons. Any other questions? No, thank you very much.
Thanks, Lyman. So we'll just get Marco set up.
Hello. All right. This is my presentation on Arduino. I'm doing a presentation on Arduino because I'm in 6th year, and for my Deep Cert engineering project, I incorporated Arduino into the control panel. So I learned lots about Arduino this year. So start on what is Arduino. They describe it as an open source electronics prototyping platform. Sort of a mouthful. based on flexible, easy to use hardware and software. And it's for artists, designers, hobbyists, and anyone interested in creating interactive objects and environments. So the whole thing about Arduino is controlling physical objects and interacting with the physical world. So why Arduino is interacting with the physical world, and Arduino in particular, it's pretty inexpensive. It's cross-platform, and it works really well on all the platforms, unlike some of the other solutions for physical stuff. So I know lots of people use Linux and Mac. So if you want to do Arduino, you'll be fine for that. And it's really simple, straightforward hardware and software that make it as easy as possible. And open source hardware and software, so you can actually build your own Arduino and write your own base software. So it's a physical thing. I'll start off with the how they look. And this is their shapes, all different shapes and sizes. And the one up the top left is the Arduino Uno. It's probably the most basic unit, like the most standard unit that you'd be using if you want to do Arduino. It's the €25 one that I use, and it can control all sorts of motors and electronics and stuff really easily. And then on the right of that you have the Mini, which is way more compact. Still running, I think, the same processor, the same amount of RAM and stuff, but it's way more compact, and you don't have the same input pins and stuff. And then on the bottom left, there's the LilyPad version, which is a nice little one. It's like they designed it for wearable Arduino stuff, so if you want to do some weird clothing projects, you can actually wear your Arduino on your clothes and sew it in. All the seams around the edge are for sewing in. And then on the right, there's the DIY Arduino. The black strip you can see along the Uno and the DIY one is the microcontroller. It controls all the logic and programming for the Arduino, and it's what you program into that, and it'll send out instructions. So you can just take that piece and program it yourself, and then just take out outputs from it and make your own Arduino board for slightly cheaper. Yeah. The bits and bobs of the Arduino. So it's not too complicated. The top and bottom layers, you can see along the top and bottom there's pins, the digital pins, power pins, and analog input pins. And you connect your wires into these pins. So you can connect, the simple one is, to get it started straight away, you could plug in one wire into the 5-volt pin, connect the end of that wire to a resistor, and then connect from that resistor to an LED, and from the LED into the ground. You have to do a resistor or else LEDs will blow up from 5 volts if you're using small ones in here. And yeah, so all the input and output pins, they output a signal, digital signal which can control all electronic devices, and input ones take signals. So you could have a circuit which has a say a light dependent resistor, which will sense the amount of light coming into the room, and through the circuit it'll lower its resistance, more voltage will go across, and it'll show up then on the input, and you can check that in the code. So you can see sort of for Arduino you have to have a pretty basic knowledge of, just a basic knowledge of electricity. So just Ohm's law, which is voltage is equal to current times resistance. And if you know that, you'll be flying along for the basic stuff. So they're the input and output pins. So you get your power for your project. If you're doing a small one, through the 5-volt pin, and then you go around the circuit, and then you put it back into the ground. For analog output, you can control lots of. There's different things take analog and different things take digital. So digital things would be lots of like LCD displays, and analog would be like motors. Then you have the USB jack, which you plug into your computer, and that's how you program the Arduino through the computer. Power jack, if you want to connect it up, once you've programmed it, and then you can just plug in a 9-volt battery, and you can power it for standalone use. And then there's LEDs up. The two RX and TX LEDs are for serial. They show up when the serial interaction between your computer and your Arduino. So if you're moving stuff between your computer and your Arduino, they'll blink along and let you know it's working along well. Okay, so for programming Arduino, it's based on C/C++, so it's a bit of a mix. The IDE is written in Java, and it's based off another open source IDE called Processing. On the right there is a simple hello. No, that's the outline of every project that you would start with your Arduino. So you have the setup, and you set up everything in the setup stage. That runs as soon as you turn on the Arduino when you've loaded it. So yeah, that sets up everything. So you'll set up pins and set up what stuff is and different variables and everything there. And then the loop is where the main project goes, and it just constantly loops and loops around that for your whole lifespan. Yes, the hello world. So I'm going to run through what a hello world thing would be. You can see here there's the LED wire coming out from ground, and then the LED connecting into one of the digital pins through a resistor. And on the right there's the circuit diagram of that. So if you want to do lots of Arduino stuff, you have to get used to the circuit diagrams. So there's the resistor and then the LED. The resistor is a squiggly line. LED is the triangular one. That's the code that you would use for your hello world. It's for blinking LED on and off. That's how you do it. So you assign one of the pins to your LED. You assign pin 13, the one that you plug the LED into. Then you set up the pin as an output one, so that you'll be sending stuff off to, and you won't be taking anything back. And in your loop, you'll write high and low after a short delay, given in milliseconds. So when you write high, you're writing full voltage, full current through, and when you're writing low, there's no current going through. So high will turn the LED on, low will turn it off, and he's just delaying while you loop, it'll turn it on and then turn it off. And then there's a picture of the cat doing its Arduino because it's so easy. There's some specs of your Arduino because when you do Arduino stuff, you sort of bring it back. Even though I never had experience of just really low power hardware and like barely any RAM and just very low clock speed and stuff. So you have to get actually careful when you're programming. You have to be very careful not to have any leaks and stuff like that. So yeah, it's just the voltage, number of pins, flash memory, 2 kilobyte RAM, 2 kilobyte SRAM, 32 kilobyte flash memory, and a 16 megahertz clock speed. So nothing compared to a normal computer. Then we have the Arduino Shields. These expand the basic functionality of an Arduino. So while with a normal Arduino you could hook it up to an LED and motors and stuff fairly easily, when you try to do stuff like controlling sound playback is very difficult on its own through just through just code and signals. So there's set shields which the shields attach onto the Arduino, and you can go through them. They'll take up a certain amount of your pins. They stick on, take up a certain amount of your pins, and then pins come up again, and you can use the ones left over. So for complex tasks, and there's ones which are input shields, which will stick on top of the Arduino, and you can use them as inputs. And one of them is the joystick, which I use, and I'll show you in a second. So here are a few shields, like a LED or LCD shield on the left, which would be very hard to do, and it sticks in. It's much easier like that. You can buy LCD screens separately and then wire them up yourself, but this literally sticks on top of it, and there's nothing more than that. And on the right again, there's another shield, which is a Wi-Fi shield, and this will give your Arduino access to the internet through Wi-Fi. So yeah, my project was a Lunar Rover. On the right there, there's the control panel, the box for the project. So we had to design the Lunar Rover and have a central switching console, which is a control panel, and then other stuff like wheels and seats and stuff. The project aims, so I wanted to control the speed of the DC motors. I would adjust the speed on the left and right motor to make it turn. So if I put more speed into the right motor and took down on the left motor, I'd end up turning to the left. And then I would use a joystick as an input device instead of, like most people in my class, is just using a potentiometer to change between the stuff, which isn't very nice to use. And it was all powered by a 9-volt battery, which is not enough for powering 2 DC motors and an Arduino. And that would retrieve me my A. Hope. So my solution was Arduino controlled, simple to control, and improved control precision. Improved control precision because it's much more precise. You could use using a joystick, and then with the Arduino I could also have done fancy things like wireless and self-driving car, which I just really didn't have time to do at all. So that's some pictures of the project there. On the left I have programming the Arduino, and I've got it set up in a breadboard. A breadboard is like it's usually a board made of plastic with copper strips laid out underneath it. So you take the pins and you pin them into the Arduino, and then you can pin them into the breadboard. And it's not like you have to solder or anything. You just stick them in, and there's copper strips underneath that'll hook the whole thing up. And this is my this was my first solution for controlling the motors, which I had a transistor and capacitors and just resistors and diodes and stuff. And it didn't really turn out that well in the end. And on the right is I was hooking up the motors. On the left you can see all the different shields I used. So on the bottom there's the normal Arduino. It's sort of a blurred photo. But on the bottom there's normal Arduino. On the top I stuck on a motor shield, which gave me really easy access to the motors and really easy to control them through it. And on the top I stuck on the joystick shield, which was perfect for controlling. And on the right you can see I just made a normal control panel just in case the examiner didn't know how to use technology at all. So, okay, yeah. Yeah, I'll just talk about the joystick. It's interesting because it works, it's like 2 potentiometers hooked up one along 2 axes. So it'll give you an XY coordinate of where you're pushing it. And through that I was able to figure out if you're pushing the joystick left or right, and then from there, I would take those values and then send them off to the motors, so I could achieve the turning and the speed that I wanted. Bouncing switches, this is a perfect example of how you're not in the digital world. So in the digital world, you just if you wanted to program something and there's a button in it, you just click the button. And then your code will say, "Oh, I clicked the button straight away. Perfect. There's no question about it." But in the digital world, if you have a physical button and you press the button, you can see here it's a steady current going through. Along this line here is probably 0 volts going through, and then so it'd be 5 volts. And then press the button, so it disconnects something. But then your button press isn't just a normal button press. There's actually like little tiny bounces in the button it'll just bounce up and down like for a millisecond or 2. And by the time you read the switch, it could have changed. So it could report as still being on because it's bounced up, even though you're clearly pressing the button. So you have to tackle this. So there's various solutions. It's called debouncing. You can wait a set time until the switch has bounced. So you can set it to, after you press a button, you can set and you get your first reading. You can just wait 2 seconds or 2 milliseconds or 5 milliseconds. Can't remember the exact time, and then it should be fine. And different switches vary. Some are huge debouncers and some less than others. And then you can pull the switch successively until it stops bouncing, So you keep asking and you see if you've gotten different values each time, and see if it's gone. And then you can do stuff like without software, that all the top was software, and then you can do stuff in the hardware, which is circuit debounce, and it's like you can run your switch through a circuit, to a certain circuit, and it'll eliminate the debouncing. It'll just act like a normal switch. Or else there's some dedicated actually hardware, like integrated circuits, little circuit things that you can stick into your circuit, and they'll fix it for you. So there's some questions and then some. Yeah, if anybody has any questions. Thank you. Just trying to figure out like the circuit diagrams and how to lay out your circuit on a breadboard, and just prototype it and and just plugging everything into the right place and stuff like that. Yep. I don't know. They haven't given in the projects for examination yet, but I'll be sure to find out anyway. They're pretty robust. You can run the wrong voltage through them or something, but they don't break on the first time you do something wrong. Usually, you'd have to do something pretty excessive.
If you bear with us for another minute, we'll just get Mark set up.
All right, guys. So my name is Mark Dennehan, and I'm going to walk you through my final year project, which was Security Shepherd, which is completely based around web application security. So I'm going to start off like a bit of a background about myself and why I even went into this space for a project. So as I was just saying earlier on, I've just finished my course in DIT, 2-in-1 computing, this year in Kevin Street. So across this course, I had a 2-year internship with an ethical hacking team. So I've been doing a lot of work with web application security. And so I kind of, across this as well as my own personal interests, I really got a really strong passion for the security space. And one of the communities that I kind of grew to love as a resource for all my academic endeavors was OWASP, which is the icon there on the right. So OWASP is a huge open source community in web application security, as well as other areas like mobile and just applications as standard. So they do loads of projects in helping you sort of like find vulnerabilities in these things, like testing projects, as well as they also release publications year to year based on what's currently plaguing the industry. So OWASP stands for the Online Web Application Security Project. So this here is the OWASP Top 10. So these are the top 10 vulnerabilities from 2010 that were found in web applications in the industry. Like pretty much everyone in the industry was making these mistakes. So I'm going to run through a couple of them. I don't really think I have enough time to go through them all, because I know Fabio, the leader of OWASP Ireland, was in here a couple of months ago and he went through these in detail. So the first one on the list, which is the most severe as far as OWASP is concerned, is injection vulnerabilities. So what these vulnerabilities are is when you have an SQL server or an LDAP directory and you're sending data that's from the user to it. So what happens when that gets there? Basically, at a really high level, it means as an attacker, when I'm giving in data, I can also give in extra code, which means that the database or the LDAP directory, as it's interpreting it, is going to execute extra code that the developer didn't mean to put in there. So this means I could return more rows than I'm supposed to be able to return. Like if I'm putting in my credit card details, what means I can't just get everyone else's credit card details back out. Or I can update other people's rows, or I can even just remove them completely from the database. So they're really, really bad. The next one in the OWASP Top 10 is XSS. And that stands for cross-site scripting. And this kind of a vulnerability lets an attacker steal your session. So it doesn't even need your username and password. He can just become you if he hits you with one of these XSSs. So they can also be used for the defacing sites. you guys might have seen maybe on the news or something like this site's been hacked by whoever. Like they just put their own mark on it. That's an XSS vulnerability. So they can be used for phishing, for stealing sessions, or for even installing malware in some cases. So XSS is the most. You can see there's a little purple block there. I don't know if you guys can actually read what's in those boxes, but that one's the only one with a purple box. That's because it's the most prevalent web application vulnerability in the industry at the moment. It's a real doozy. So injection and XSS, they're very clear case. You shouldn't be able to execute code in the server. You shouldn't be able to execute the code in someone else's browser with XSS. So the third one is broken authentication and session management. So this is a little bit more vague because it's not so clear case. There's no list for exactly what to do to find these things. It might actually be unique to your authentication schema or your session management schema. So broken authentication is when I can bypass your authentication. I can become somebody else by just changing some of your tracking things. The last thing I'm going to run through really quickly is A5, which is cross-site request forgeries, which are also it's a really widespread problem. This type of vulnerability basically lets me do whatever you can do with your application. So let's say this is sending an email. So if you send an email, I can make you send an email. So I can make you send an email to your boss saying that I quit. This sort of thing. This is done when there's a predictable request. And I mean, some of these things are kind of difficult concepts, but this is why I wanted to make Security Shepherd. So there's a defined list in the industry. These guys are making a new publication every couple of years. So you'd imagine that it's very easy to hire a team and they're just going to get it right. You're not going to get hacked. But all of these companies here on the screen this year have had their web applications hacked through vulnerabilities described in the OWASP Top 10. So this is obviously a really serious problem. Why are these mistakes still being made? And I kind of felt that it had something to do with the security awareness in the area, because a lot of people weren't familiar with these vulnerabilities. So if you want to go out there and you want to get more familiar with web application vulnerabilities, what was already done, what could you do? So there was a couple of projects that had already been done. One of them was made by OWASP themselves, called WebGoat, and it's already received a really high degree of success. It's very popular. It simulates all the vulnerabilities, so you're not sacrificing any security from anyone. But sometimes modern attack vectors mightn't work because you're not giving them their correct answer, you're giving another correct answer. But it's got a really wide coverage, and it covers so many vulnerabilities that if you can get through all the OWASP, if you can get through all of OWASP WebGoat, you're really off to a great start. In contrast, DVWA, which stands for Damn Vulnerable Web Application, is very, very, very similar but very different to WebGoat because it doesn't simulate its vulnerabilities. They're real. You can use these vulnerabilities to destroy the application, so no one can use it anymore. Or even yet, you can compromise the environment that it's running on. So you can completely destroy a machine when that's running on it. It's damn vulnerable. It's in the title. This doesn't cover all of the OWASP Top 10. This covers about 40% of it. It's more about really, really breaking machines. So Security Shepherd was really about merging the two of these together. It's not simulated. It's not fully vulnerable. So they're real vulnerabilities in this application, but they're presented in a way that they can't be abused to destroy the application or its environment. And it covers 100% of the OWASP Top 10. So I'm going to actually run you guys through some of what's in Security Shepherd. So I don't want you guys to go home and decide, this is great, no one knows how to do this, I'm going to go hack people. It's going to be great. I work in ethical hacking, and it's ethical hacking. It's a white hat environment. If you do this to someone else, chances are you will get caught, and you will get prison time possibly. Someone didn't take this advice very recently, and they got sentenced to 1 year in prison. So don't mess around with this stuff. It's pretty serious. So what I'm going to start off with is something really, really easy. It's the first level in Security Shepherd. And it's just to set you off. It involves me using a HTTP proxy, which means I'm able to stop the requests that actually leave your browser before they get to the before they get to your web application server. So you can do a lot of damage to an application with a browser and a bad attitude. but using a proxy makes things sometimes a lot easier. So here we go. So this is actually the application here, and I'm signing in as myself. At the moment, it's in a lessons and challenges format here. You can see on the left-hand side. This is very easily changed into a capture the flag environment where you're actually competing against other people who are taking the application. So it kind of becomes more like a game. So you can see here, I've loaded up the lesson, and how it works is that there's a lesson to begin with to give you a brief overall of what the vulnerability is before it gives you harder levels. So I'm going to hide the lesson introduction because I'm jumping the gun here. So the objective of the level is to look at the administrator's profile to get the key to pass the level. So I'm clicking this button, and I keep loading up the guest user. There's no parameters there that I can see. So this is my HTTP proxy, and when I've turned it on now, and when I click this, we can see that I've actually caught something. And then here, you can actually see that there's a pretty dodgy looking parameter that's been sent, which is name equals guest. So it's directly looking up what's in the system based on that parameter. So I'm going to change that to admin and forward that back to the web application server. And we can see that now I've loaded up the profile for the admin. So that's a really, really slow start. And as I said, it starts off with lessons before it gives you a challenge. These get more difficult. So you should be able to start off going, right, well, you're not supposed to be able to give that to the user to pick what they're going to look at. But it gets a little bit more difficult. And you're going to, if you go through the application as an entire entity, you'll learn what insufficient protections there are against this sort of stuff. So the next thing I'm going to go through is cross-site scripting. This is the most prevalent one. This is the one with the purple blob that I was just talking about earlier on. This is a really, really bad defect to have in any application. So here we are. I sign in again, and I'm going to kick off with the base lesson for cross-site scripting. So I have no problem showing this level off to you guys because, as you can see, there's going to be loads of help here to pass this level. It actually gives you sample HTML in case you're not even familiar with HTML and how to execute JavaScript. So to give you an idea of what exactly is going on here, I'm going to put in test and submit that in this search bar. And we can see that it's going to return, sorry, there was no help. There was no results for test. It's spitting out exactly what I'm putting into the server, back out to the client's browser. So instead of putting in just test, I'm going to put in bold tags around test. So you would imagine that it would see those tags again when they come out on the other side. But in fact, test comes out bold. The browser's consumed that HTML. It's executed that HTML. That doesn't seem that bad, but when I go to put in script tags instead, I'm actually able to make someone else's browser, if I was to make them submit this, I'm able to make them submit it, and then their browser will execute JavaScript as it loads it up. So that doesn't seem that bad. That was just a pop-up. And it's something I hear all the time, that XSS is just a pop-up. Who cares? So here's an example of a phishing attack through XSS. We can see here that there's a commonly used email login page that loads up. And now, if you can imagine, the user clicks a trusted link, and then they get this to sign in. They're going to put in their username and password. And then this hacker's been very friendly, and he's just going to give a pop-up saying that you've been hacked. I have your username and password. What I could be doing there is I could be forwarding on that information to my remote server before redirecting the user to the actual service. So they don't even notice that their credentials have been sent on to someone else. So that might look a bit fishy even. I mean, like, why would I be signing into this email inside Security Shepherd? If you can imagine I found an XSS inside the email and you just load it up and you think, oh, it's been logged out. You'd sign in, no problem. I mean, it's very easy to get people with phishing attacks even when they think they're really good at avoiding them. So that was XSS, a really quick blitz through XSS. And these so far have been quite easy as far as these things go, and there's a lot of help there. So I'm going to give you an example of one of the challenges that you might face. I'm going to give you an example of broken session management and broken authentication and bad session management. So this is a challenge. So this is one of the things where it's not so clear case, and it actually requires a bit of investigation. So hacking is not always easy, and it's something you really have to learn is patience. And you gotta be able to put in the time. So we can see here that the objective here again is to become the administrator. And I've clicked the admin only button, and it says I'm not an admin, so I don't get the password. So I'm going to use my HTTP proxy again to intercept what's going through the application. So we can see that there's actually a lot of stuff. Some of it's been cut off here, but there's a really fishy-looking parameter here called admin detected that equals false. So I'm going to set that to true, because obviously it'll think I'm an admin. But obviously there's some protection in place here, and it knows that I'm not an admin because something's not matching. So that wasn't my solution. So there's an upgrade user to admin. So maybe if I send the request with this, I'll be upgraded to an administrator. But sadly, this isn't the case either. So obviously there's some insufficient protection here, and maybe I'm going the wrong way about it. So I'm going to have a look and play around with combinations of these true-false values. We're kind of blessed that I know there's something wrong here. I know this isn't secure. I know I can break this because it's in the game. But if you can imagine, this is an environment where you don't always know that that's there. So I'm going to look elsewhere. I'm actually going to look in the cookies of the request. And we can see there's a checksum. And I can see that I know that this is encoded in base 64. But you'll encounter this earlier on in the game. Base 64, for those of you who aren't familiar, is very easy to decode. It's not encryption. It just makes the data more obscure. And I know you can't see it there, but that encoded value actually turns into user role equals user. So I can just change that to administrator, re-encode that for base 64, and submit it back to the server. So what was actually the vulnerability there? The application was tracking the user's state with a cookie. So it was checking, are you an administrator? I'm actually going to read it off this cookie. If you can imagine, that might as well just be saying not an admin, and I could just change it to saying admin. But it was just obscured a little by being encoded in base 64. So these mistakes are really easy to make, and there's a lot more in this application. I really just blitzed over it quite quickly. This is just the feedback process that I had in place for, I improved the application based off my user input, so you had to submit that before you even got past the level. Very bold. So that's the application. This application is already kind of receiving a high degree of success. I'm working with the OWASP leader of Ireland at the moment, getting this moved into a OWASP official open source project. So this is going to be hitting the stage pretty soon. It's going to be making its proper debut at Google GTUG and OWASP Hackathon in July 7th and 8th. So this is going to be a really fun event. Security Shepherd is going to be running live for everyone to give it a go and try hack their way into it. And it's just going to sort of just teach you what am I doing in my applications that I could be doing more secure. So if you guys are interested, that's actually the QR code for the sign-up page. And what's going to happen at this event, there's going to be an attack seminar, which is going to be Security Shepherd. There's also going to be defense stuff in there. I think there's going to be some other stuff, but I'm not so sure if it's happening, so I'm not going to say it out loud. That's actually all I've got. But if you guys have any questions, I'd love to take them. Fire ahead. Yeah?
I guess you are somehow connected to local guys from PCI.
Sorry?
I would assume that you are somehow connected to the guys from PCI, DCC.
PCI and DCC? No. No, I'm just graduating.
Okay, so
this is
question will be even more interesting. So if you are looking for the project, for example, where for the team performance involved the computer vision, how would you think how to hack it right away?
That's sort of something that I'd love for someone to get by going through this application.
Okay.
You'd sort of look at something and go, that looks insecure. It kind of depends. If I'm looking at it, I might go, immediately. I might see how it's passing a parameter, and I might think that looks like injection, or that looks like cross-site scripting. But really, my first thought would never be to hack it because I'm an ethical hacker, and that you should never be doing this to other people's applications. So do you mean when, for example, if you're putting your credit card into somewhere, do you want to know if it can be hacked?
So you are using, for example, because it's already out there. So you can use your computer camera to scan your credit card front side, which would, the computer vision recognize, detect the numbers and other stuff.
Okay.
Whatever it is, and then just confirm by tapping your CV on the other side. So do you see some way how to have even this first stage, the computer vision recognizing the...
What could be a problem, I'm not familiar with the service, but something that I didn't cover in detail is in the OSAT 10 was, I think, number 9, which is insufficient transport protocol. So what if you're not doing that over a secure line? You're not doing it over HTTPS.
Well, right now it's done via, it's
I don't know. I'm not. I genuinely don't know. But it's like pretty much every communication is vulnerable to network attacks even. So it would.
Does it work to or this to count on covering even this kind of topics?
This tool doesn't. This tool at the moment, because it was my final year project, I wrote the whole thing in two. I had a few months for design, but less than 2 months for implementation. So I only covered the OWASP top 10. So I'm sure there's some way to abuse it, but it's too specific an example, I suppose. Sorry, sorry? Is there any other questions? Yeah? Denial of service attacks aren't in the OWASP top 10, but it's something that they do in the community is covered. But I mean, you could utilize the OWASP top 10 to perform a denial of service. They're actually quite vague, and you could actually apply nearly 90% of the vulnerabilities out there to exploitations. For example, like an insecure direct object reference, which is what the first video I showed, where I'm looking up directly the user I'm looking at. So if you can imagine there's millions of rows in a table, and it's expecting me to be only retrieving one. What if I put in a star instead, and it looks at loads? And I distribute that to loads of people to send. All of a sudden, that could be used as a denial of service against the application. That answer your question? I might have run off. So no, denial of service isn't in the OWASP top 10, but it's not all about escalation of privileges. It can be about different kind of stuff, just like looking at other people's data or removing other people's data, which I suppose is an escalation of privilege if you really want to look at it that way. Sorry, yeah? On what data? I'm not so sure how they decide which are the top 10 or where they get their data for it. I know that they arrange the order of the top 10 based off of a threat matrix. I don't know if anyone in the audience knows. No? It's based on attacks. So it's based on publicized attacks. Any other questions? Anyone interested in going to the hackathon in July? Good, good.
That's great. Thank you.
All right, cool.
So this already went out on the mailing list earlier in the week. The Google Technology User Group is going to be rebranding to the Google Developer Group Dublin. It's a worldwide rebranding of the GTUG brand. There's a logo animation competition which went out on the mailing list again. If you're interested in animation at all, you should definitely take a look at it. There's some prizes being sponsored by Google. They were explicit that does not include an I/O ticket. So what does that actually mean? Not very much, really. There'll be a new logo. We'll change the Twitter name. There'll be a new mailing list, which will send invites to anybody on the current list. We considered moving everybody over, but it seemed a bit wrong to assume everyone would want to. There's more details to come at Google I/O when the official announcement will come out. And I don't know if there is any more, but there might be. But if there is, you should come along to I/O Extended, which will replace next June's meeting. So there'll be no Tuesday meeting next June, because I/O Extended is on the Wednesday, which will be after that. So that will kick off at about 4:30. It's a live stream of the keynote from 5. We've got a maximum number of places of about 110, but we're only at about 50 signups at the moment, so it's not really an issue right now. No? Are we? Oh, we're almost full. I didn't know that. I haven't checked it in about 2 or 3 days. It's really shot up. Okay. So we'll have to put in place a wait list then if that happens. So if you want to go, sign up soon. There will be some swag, though I do know that won't include phones and tablets for everybody. So sorry about that. They're optimistic you might have some nice spot prizes for 1 or 2 people. As Mark mentioned, is the Security Hackathon. That will be July 7th and 8th, and it's going to be over in the Grand Canal Plaza building. It's the 2 days. So we'll go through the Security Shepherd, and I've already told Mark I know, well, I sort of recognize a lot of those terms, but I don't know much about them, so hopefully I'll learn a lot as well. And there's the URL and the same QR code. And Yeah, I mean, you guys make the group, so if you have any suggestions, anyone who wants to get up here and talk about things, we'd love to hear from you. Get in touch, and thank you all for coming. We'll be heading around to the schoolhouse pub for a pint or two. Thank you very much. Definitely thank all the speakers. I should have said that.